Hello everyone, I am Professor Rachana Mahule from MCA Department, PR Pote Patil College of Engineering and Management. We are learning about the subject Design and Analysis of Algorithm. And we are learning about the divide and conquer technique here. In last lecture, we have completed the algorithm for finding out the minimum and maximum number from the array, from the list. Now today we are going to learn about another example of divide and conquer algorithm, and that is quicksort algorithm. The quicksort algorithm is based on divide and conquer approach in which the array is split into subarrays and these subarrays are recursively called to sort the element. Now, as we are knowing that this algorithm is having the approach that is divide and conquer approach, we will see what is meant by divide, then conquer and combine in this quicksort algorithm. It works by partitioning the elements into two parts. So here we are using the arrays. We are going to first partition that array and then we are going to recursively call that all arrays and then we are going to sort these array. So let's start just learning about the divide, conquer and combine in the quicksort. So the divide, here we are going to talk about the divide first. So here divide means the array is divided into subparts, taking the pivot as a partition point. Here we are choosing pivot as a partition point. Now here suppose we are having S is the list, given list. Here we are selecting one pivot point which is denoted by V here. So that pivot is the partitioning point. The elements smaller than the pivot are placed to the left of the pivot and the elements greater than the pivot are placed at the right of the pivot. So here the element which are smaller than the pivot are placed at left and the elements which are greater than the pivot are at the right hand side. So here we are getting the partition of our list. In the partition is we have the pivot point which is now at the proper place in the list, but all the elements which are less than this pivot are placed in the sublist S1 and which are the greater elements than pivot are placed into the sublist that is S2 here. So that is what here the single that list that is denoted by S is now divided into two sublists. Now these two sublists are recursively called. So this is what the divide part of the quicksort algorithm. Now we will see the conquer part of the algorithm. Conquer means the left and right subparts are again partitioned. Here we have the conquer, in that it is recursively sort two subarrays. To again sort these two subarray, of course the left and the right subparts are again partitioned using by the selecting pivot elements from them. So here we have to choose again one pivot. This can be achieved by recursively passing the subparts into the algorithm. Means here we are calling the same function, that is the quicksort function for these lists. So that is what the conquer. So again this list will be divided into two parts. Then by choosing the pivot, this list also divided into two parts by choosing the pivot, and it will go up to the last element, that is sorted element. When we got the sorted element, then we are going to combine all that sublist. So last one is the combine part here. This step does not play a significant role in quicksort. The array is already sorted at the end of the conquer step. So here actually what the solution we are getting, The solution is we are getting the sorted list, that is S1, S2, and the pivot is at the original position in the first step there. So that is what we are getting directly, the combined list here. So that is what actually we are getting, the S1 pivot and S2 list, sorted list are there. So that is what the combined step in the quick sort. So here let's start with the example. Now how we are going to choose the element and how we are going to sort that algorithm. So here we have the quick sort steps. So here what we are doing, first is choose the partition element to be the leftmost element. Now here in our example we are choosing the pivot, that is the leftmost element. This is nothing but your pivot value. Okay, so in our example we are choosing the pivot element. You can choose any position for the pivot element. Generally the left element or the top right element is used as a pivot element. Here we are choosing the leftmost element as a pivot. Then here we are going to scan from left. Whenever we are scanning the element from the left to right, we are going to find out the larger element. Remember this step. When we are going from left to right, we are going to find out the larger element. When we are scanning from right to left, at that time we are going to find out the smaller element. As we are, suppose we are having this list, and in this list if we are choosing this one as a pivot, so here the pivot's less than element should be at the left hand side and the greater element should be at the right hand side. For that purpose, here we are having, from when we are starting with this left side, if we found the element is larger, it has to go at the right hand side of the pivot. And if we are going to search the element from the right hand side, of course that element is smaller element and it has to be placed at the left hand side of the pivot. So that is what the intention is. When we are going from left, we are going to find out the larger element. When we are going from right, we have to find out the smaller element. If we found these elements, from left larger element, from right smaller element, we are going to exchange it. And we are going to repeat this until the pointer cross, means until the pivot element is crossed here. So that is what the steps. Now we are going to learn it with the help of example. Now here we have given the array, and in that array we are having 9 elements. Here n is nothing but the actual, here n is nothing but the size of element, and here in our example n is equal to 9. So let's start with this. This list is the unsorted list, and we are going to sort this list by using the quicksort algorithm. So the very first step is we have to choose the pivot element, and we are choosing the pivot element, that is here the leftmost element we are choosing as a pivot. If we are talking about the that array, of course we are starting with the index 0 and we have to end with the index 8. Okay, as we are having 9 elements, it is starting from 0 and it is ending at 8 here. Now in this algorithm we are going to choose the pivot is here 40. Now here we have some actually we have some variables here, that is location. First is location, that is loc is equal to 0, left is equal to 0 and right is equal to 8. First we are choosing the pivot element, so location will be 0. The first element we are choosing as a pivot, location is the 0. Now left is nothing but here again 0 because we have to choose the leftmost element here. So that is left is equal to initially 0 and right is equal to the rightmost element, that is 8. So here we have to think about three different variables: location, left and right here. Most of the time there are the variables that is beginning and end. Okay, here we are choosing 0, then the location, left and right. Now let's start with the actual procedure. Now in the first line you have the procedure. In that we have quick. That quick is nothing but actually the name of your algorithm. That is, here we have quick. Now that is what the quick. Then here we have A. A is nothing but your array. Second is N. N is the size of your array. Then beginning. Beginning is the start of your array. End is the end of array. And after that we will have the location. So the location is at what pointer we are having. At the current, what is the current pointer? That is nothing but the location here. Now why there is beginning and end? Because we are going to sort our list by using the divide and conquer method. Here always we are going to put different list. So for that, whenever we are having the partition, always we will have different start and different ends here. For that purpose, here we are using the names, that is beginning and end. Now let's start with this algorithm. So here we are having the algorithm. In that we have already started with here the 40. 40 is nothing but your location. Then left is actually where you are. You are at the left hand side. Our pivot is at the left hand side. Okay. And the right hand side is nothing but the last element of your array. Now we are going to repeat the steps. Now how? We are going to check here A of location. Here we have the condition. Two conditions are there. When we are at the left, we are going to find out the element from the right. We are knowing that from right, we have to check for the smaller element. Okay. So we are starting with the rightmost element and we are going to find out the smaller element than the pivot. So let's start with the first element, that is 100. The element is 100 and the location is, the left element is 40 and the right element is 100 here. So we are going to check the first condition. That is what? Here we have to repeat it up to what? Here we are going to check the location. A of location is less than or equal to A of right. We are going to check it. A of location. Location is 0, that is mean by 40. And it should be less than or is equal to A of right. A of right is 100. 40 is less than or equal to 100. That is what the condition. And location is not equal to right. Here the location is actually left. It is not right. The condition is true here. So we are going for the another line, that is right is equal to right minus 1. Because A of location is already smaller than the right hand element. So we are finding the smallest element, smaller element than your pivot. So we are going for the previous, right minus 1. Now again we are going to check A of location is less than A of right. Here the A of location is 40 and the A of right is here actually 30. The condition is false here. We are going for here the second part, that is A of right is now 7. Now we are going to check, is it smaller? 40, here we are going to check the location and the A of right is smaller. A of right is smaller, so we have to go for the exchange. So what we are going to change here? We are going to exchange locations here. So location is equal to right. So the 40 will be at the 30 at the place of 30 and 30 will be at the place of 40. So here one element is sorted, that 30 is less than 40 and it is at the left hand side of the 40. So that is what we are going to exchange that values. So here we are moving here, like the 30 here is placed at the location of 40 and 40 is placed at the location of 30. Now here the 40 is at the right hand side now and 30 is at left hand side, and the location is what? Whenever we are changing the positions, at that time only we will have this location change. The location will change when we are using or when we are performing interchange there. So that is what here we have. The right hand side is now 40 and the left hand side is now the 30. Now if our pivot is at the right hand side, we have to go for searching the element from left hand side, and from left hand side we are going to search for the larger element. So here we are going to compare 40 and 30. We have already compared it. Now it will go for the next position, that is here we have the condition, that is A of location, that is A of right is greater than A of left. Is greater than A of left? Yes, it is greater than A of left. And the location is not left. The location is right here. So what we have to do? We have to do, that is left is equal to left plus 1. So we have to move for the second position here. Again we are going to check here, is 40 is greater than 20? No, again it is not greater than 20, so we have to go for left is equal to left plus 1. We are moving for the next position, that is 10 here. So here always we are going to check the actual position. Now here we are moving to the next position, that is 80. Again we are going to check here at the 40 and 80 are what? The 40 is less than 80. So here the A of left, here we found that A of left is greater than A of location. Yes, the condition is true. So here we are going to interchange that positions. Then here we have location is equal to left. We have to move 40 to the left hand side. And here we are again going for the go to step 2. We are going for the previous step. Means here we are going to start with the for searching from right hand side. So always we are choosing the elements. If the pivot is at the right hand side, we have to move from left hand side. If our pivot is at the left hand side here, so we have to move, we have to check for the element from right hand side. Always we are going to do this. So here we are going to check whether 40 is greater than 7. Yes, 40 is greater than 7. So 7 should be at the left hand side and 40 should be at the right hand side. Now again here we have to check 40 is less than 60. So 60 should be at the right hand side of the 40. So we are going to do like this. We are now at the position, that is left is equal to 4, right is equal to 4, means location is equal to right. We have started with the left and now we are having all the positions that are same. Means we can't move at left hand side and right hand side, means we are reaching to the pointer. So that is what here we cross the actual pointer here. So here we have the position of 40 is now fixed. All the smaller elements are at the left hand side of the 40 and all the larger elements are at the right hand side of the 40. So that is what the first pass here. We have position of only single element. Now we have to recursively call this quick algorithm for this left hand side, and for this right hand side. Okay, so here we will have the beginning for the left hand side is 30 and the end for left hand side is 7. Beginning for the right hand side list is 50 and the end for this right hand side is 100 here. So now we have, after getting the pivot position, we are having two sublists. So of course we have two start and two end here. We have two beginning and two ends. So here we have to put that two beginning and two ends in the stack. Remember, here we are going to put that two values in the stack. So this is the quicksort algorithm, is also called as application of the stack. So here that is what we have learned about only the quicksort procedure. What is generally it is recursively called. Now here we have to use the stacks also. So here we are going to talk about the whole algorithm. So here what we have found out, we found out that the actual position of 40 is in the middle and here we have the first sublist and here we have the second sublist. So here we have to recursively call the same procedure, the same quick procedure here. So that is what the actual algorithm here. Now see carefully, we are having this algorithm. So it is a quicksort algorithm which is starting with top is equal to null. Now here the array is A with n elements and we are initializing that top is equal to null. The top is nothing but the actual element position, topmost position of the stack. Generally what we are having in the stack, whenever we want to insert the element, we have to insert the element at the top. So that is what here initially the top is null. Now here push boundary values of A into stack when A has two or more elements. So what we are going to put? We are going to put the values into the stack. Initially we are having n elements, so lower is equal to 1 and upper is equal to n here. Now see, here lower and upper are the two different stacks, right? So two different stacks are there. So very first value which is going in the stack, lower stack, is 1 and here we have the upper stack is 9. Now see, here we have the example. The lower value of the stack is 30 and here the upper value is 100. Okay. Now what original message, what was our original list? In that the leftmost side will be the first element and rightmost side will be the second element. Here what I have given is nothing but the whole sorted list, the what we have found out. We have here the example, that is pivot is at its proper position, but here initially what we are going to place 40 at lower and here we will have the last element, that is 100 at in the upper position. Now after that here we have to repeat it. We have to repeat it, and while the top is not equal to null, we have to repeat it. Means again we are going to repeat for the sublist. Here we have the left hand side sublist. So the first element will be 30 and the second element will be 7 here. So in the lower we are going to put 30, that is what the position of 30, and here the position of 7 here. That is what we are having 0 and 3 at the lower. In lower the second position is 0 and in upper the second position will be 3. In lower the next position will be 5 and the upper position will be 8 here. And then we are going to call our quick procedure here. So always we are going for the recursive call. When the first list is sorted, the smallest portion of the list is sorted, we have to pop the element from the actual stack. So that is what first we have to push the elements into the stack, and then we are for the left hand side we are using this particular values, some particular statements. Here we are for pushing the elements into the right sublist, we are using top is equal to top plus 1 and lower is equal to location plus 1. So that is what different values we are placing here. Now see what actually is happening. Here we are having the very first position is, here we have lower and upper. The lower is 1 and upper is 9. Okay. So in our original example, the lower is 1 and upper is 9 here. As we are starting with 1, so here it is 1. If we started with 0, so here the upper will be 8. Okay. So the value of upper should be 8 here. So here we have the very first, the whole list is covered here. That after getting the pivot at the location 5, we will have two sublists. So here the first sublist is lower will have now the value that is 1 and upper will have the value that is 4. And the second sublist is the lower value is 6 and the upper value is 9 here. Now always the stack is going to be updated. Now of course that 6 and 9 will be first pop up here. So we will have to perform the recursive call for this particular portion. So we are going for that. Here we have to just pop up that value. So here we will get the different values for that, different elements for that. That is what first we are going for. We are going to choose the pivot here. Then we are getting the actual position of the element, that is 50 here, and we will have the sublist this one. Then 7 and 9. That 7 and 9 will be put into the stack, that is 7 in the lower stack and 9 at the upper stack. Again we are going to put the pivot, that is equal to 60, and again we are going from left to right here. We are going to search from right to left. From right to left we are going to search for small value. There is no small value, so that 60 is at its proper position. So the next element into the stack will be 8 and 9. So that is how that stack is going to be modified. Always the values for the list are updated there. That is lower and upper values are updated, and it will go until the last element. So here we have the actual working of the quicksort, and lastly what we are getting the actual positions of the values here. 7 is smallest, then here we have the after this here we have to again check 2 and 3 are in the stack, and here again we are going to check. Here the 20 will be the pivot. We are going to check for smaller. Yes, 10 is smaller, so we have to exchange it. So we will have the values, that is 7, then we have 10, then we have 20, then the 30, 40, 50, 60, 80 and 100. So the list is sorted here. So That is what the divide and conquer method used in the quicksort algorithm. So the quicksort algorithm is having the complexity that is n square. The complexity of quicksort algorithm is n square. The worst case, big O of n square. The complexity of this algorithm when it is in best case is n log n, and it is the average case also, that is n log n. So that is what the quicksort algorithm. From next lecture we are going to start our third unit. So up to this it is the divide and conquer technique. We have